Time travel is a concept that has captivated the human imagination for centuries. It is the idea of moving backward or forward through time, much like we travel through space. Imagine witnessing historical events firsthand, or catching a glimpse of the distant future. The very notion of time travel raises profound questions about the nature of time, reality, and our place in the cosmos. Time travel is a staple of science fiction, inspiring countless stories, movies, and TV shows. From H.G. Wells's The Time Machine to the iconic DeLorean in Back to the Future, time travel has fueled our dreams of exploring the unknown corridors of time. But is time travel merely a fantasy? Or could it be within the realm of scientific possibility? As a scientist, I'm always intrigued by the boundaries of what we know and what we don't. Time travel, with its mind-bending implications, sits squarely at the intersection of science and imagination. To understand if time travel is possible, we need to delve into the realm of physics, particularly Einstein's theory of relativity, which revolutionized our understanding of space and time. Join me as we embark on a journey through time, exploring the scientific concepts, paradoxes, and possibilities that surround this captivating topic. When we talk about time travel, we often think about venturing into the past, but traveling to the future is actually a less complex concept. In fact, we're all time travelers in a sense, moving forward through time at a steady rate of 1 second per second. However, Einstein's theory of special relativity, proposed in 1905, revealed that time is not absolute but is relative to the observer's frame of reference. One of the most fascinating consequences of special relativity is time dilation. This phenomenon predicts that time passes slower for objects moving at high speeds relative to a stationary observer. The faster an object travels, the slower time passes for it. This effect has been experimentally verified countless times, confirming Einstein's revolutionary theory. Imagine a spacecraft traveling at a significant fraction of the speed of light. Time inside the spacecraft would slow down relative to time on Earth. If the spacecraft were to return to Earth after a long journey, years, decades, or even centuries could have passed on Earth, while the astronauts aboard would have aged significantly less. While we haven't yet achieved the technology to travel at such speeds, the concept of time dilation suggests that forward time travel is indeed possible, albeit at a slower pace than we might imagine. Traveling to the past, however, presents a much greater challenge and delves into the realm of theoretical physics. While forward time travel is supported by experimental evidence, backward time travel remains highly speculative. The laws of physics, as we understand them, do not explicitly prohibit traveling back in time, but the implications and paradoxes it raises are mind-boggling. Imagine the possibility of altering past events or meeting your younger self. The very notion of changing the past raises questions about causality, free will, and the nature of reality itself. Could we change the course of history? Would altering the past create a ripple effect, fundamentally changing the present? Theoretical physicists have proposed various mechanisms for backward time travel, often involving exotic concepts like wormholes and closed time-like curves. However, these concepts remain largely theoretical, and their existence has yet to be confirmed. To comprehend the possibilities and limitations of time travel, we must understand the groundbreaking work of Albert Einstein. His theory of relativity, which includes both special and general relativity, revolutionized our understanding of gravity, space, and time. Special relativity, as we discussed earlier, deals with the relationship between space and time for objects moving at constant speeds. General relativity, on the other hand, expands this concept to include acceleration and gravity. Einstein proposed that gravity is not a force but a curvature in the fabric of space-time caused by massive objects. Imagine a bowling ball placed on a trampoline. The ball causes a dip in the trampoline's surface, much like a massive object warps space-time. This curvature of space-time is what we perceive as gravity. Objects, including light, follow the curvature of space-time, causing them to be attracted to massive objects. General relativity has profound implications for time travel. If space-time can be warped and distorted by massive objects, could we potentially manipulate it to create shortcuts through time? One of the most intriguing concepts in theoretical physics, often associated with time travel, is the wormhole. A wormhole is a hypothetical shortcut through space-time, connecting two distant points in space and potentially different points in time. Imagine folding a piece of paper in half and poking a hole through it. The hole represents a wormhole. connecting two distant points on the paper's surface. While wormholes are a theoretical possibility within the framework of Einstein's equations, their existence has not been confirmed. Even if wormholes do exist, it's unclear whether they could be traversable by humans or spacecraft. The energy requirements to create and stabilize a wormhole are thought to be astronomical, far beyond our current technological capabilities. Despite the challenges, the concept of wormholes continues to fascinate scientists and science fiction enthusiasts alike. If we could harness the power of wormholes, they could potentially unlock the secrets of time travel, allowing us to journey to distant stars and perhaps even different eras in time. Time travel, particularly backward time travel, is fraught with paradoxes that challenge our understanding of causality and the very fabric of reality. One of the most famous thought experiments is the grandfather paradox. Imagine a scenario where you travel back in time and, for whatever reason, prevent your grandfather from meeting your grandmother. This seemingly simple act has profound consequences. If your grandfather never met your grandmother, one of your parents wouldn't have been born, and consequently neither would you. But if you were never born, how could you travel back in time to prevent your grandparents from meeting? The grandfather paradox highlights the potential contradictions and logical inconsistencies that arise when we consider altering the past. Several hypotheses attempt to resolve this paradox, including the idea of parallel universes or the Novikov self-consistency principle, which suggests that the universe would somehow conspire to prevent paradoxes from occurring. The concept of time travel raises fundamental questions about the nature of time itself. Is time a river, flowing in one direction, or is it more like a dimension that we can navigate? The second law of thermodynamics, often referred to as the arrow of time, suggests that time flows in one direction, from a state of order to disorder, or from low entropy to high entropy. This law governs the direction of many physical processes, such as the melting of ice or the expansion of the universe. However, the laws of physics, as we understand them, do not explicitly prohibit traveling backward in time. It's possible that our current understanding of time is incomplete, and that there are aspects of time that we have yet to uncover. The question of whether we can truly change the past or future remains a subject of debate and speculation. Some physicists believe that the past is fixed and immutable, while others entertain the possibility of a dynamic and changeable timeline. Time travel has been a recurring theme in science fiction for over a century, inspiring countless stories, movies, and TV shows. From H.G. Wells's groundbreaking novel The Time Machine to the iconic DeLorean in Back to the Future, time travel has fueled our imaginations and sparked countless debates about the possibilities and paradoxes of navigating the corridors of time. Science fiction often explores the ethical and philosophical implications of time travel, delving into questions of free will, determinism, and the consequences of altering the past or future. Works like 12 Monkeys and Primer grapple with the complexities of time travel, exploring the potential dangers and unintended consequences of tampering with the delicate fabric of time. While science fiction often takes creative liberties with the concept of time travel, it also serves as a source of inspiration for scientists and engineers, pushing the boundaries of what we believe is possible. So, is time travel truly possible? The answer, as with many things in science, is not a simple yes or no. While the laws of physics do not explicitly rule out time travel, it remains a highly speculative concept. Forward time travel, through time dilation, is a well-established phenomenon supported by experimental evidence. Traveling to the future is indeed possible, albeit at a slower pace than we might imagine. However, backward time travel presents significant challenges and delves into the realm of theoretical physics. The paradoxes and implications of altering the past raise profound questions about causality, free will, and the nature of reality itself. While concepts like wormholes and closed time-like curves offer tantalizing possibilities for backward time travel, their existence remains purely theoretical. Even if such phenomena exist, the technological hurdles to harnessing them for time travel would be immense. As a scientist, I'm driven by curiosity and a desire to explore the vast unknown. While time travel might seem like the stuff of science fiction, it's a topic that continues to intrigue and challenge our understanding of the universe. Whether or not we'll ever unlock the secrets of time travel remains to be seen, but the pursuit of knowledge and the exploration of these mind-bending concepts will undoubtedly lead to new discoveries and a deeper understanding of the cosmos.